Hello, my name is Steve Cho,
Hello, my name is Ganfang.
Hello, my name is Deepam Patel.
and our group's final project is about improving the mobile ChatGPT application's performance using prefetching. So the ChatGPT is widely used OpenAI application that works as chatbot, where we ask questions and the bot will answer the question within a short period. So as such, it's easy and simple to use because all you have to do is start the application and ask some questions and you get the answer. And ChatGPT answers not only a single type of question, but almost all categories of questions that you're interested in. And it also gives suggested solutions in no time. However, there are some inconveniences to using ChatGPT, which requires a login to the website to use the application. And it does not include a speech to text or text to speech function. And you have to type the question into the prompt and read the answers. So sometimes it may be tiresome if the questions you want to type in or the answers you receive are lengthy. So it would be a waste of time, especially when the suggested answer is not what you really wanted. So we would like to introduce the ChatGPT-on-Phone, which is an application that changes the way we interact with the current ChatGPT format. So this application is unique in the way that it leverages advanced AI to enable speech-based interaction. So with this application, there's no need for typing or reading text. Simply, you can just speak your query and you'll get the spoken answers directly. So as we will present in the details of the optimizations later in the presentation, this application is optimized for rapid responses. So our advanced algorithms ensure that you get the answers you need quickly with fewer delays. So we'll look in depth at how ChatGPT phone operates behind the scenes. So on the client side, which is the user's phone, the app starts by taking the user's spoken or written input, and it then applies the local optimizations to ensure that query is clear and ready for processing. So this optimized message is then delivered to our server. So once the server receives the message, it triggers the next stage of the process. Here, the server's job is to take these questions from the client and run them through the ChatGPT model to fetch the appropriate answers. So after computing the response, the server sends the answer back to the client. On the client's end, there's a brief wait for this answer to arrive. So once it's received, it plays the answer to the user through the device. So the primary issue is that is the latency. So when a user asks a question, the server may take considerable amount of time to respond, especially under condition of a unstable network. So this can mean like several seconds of delay. So as we all know, when it comes to technology, users, they expect an instant response. They don't want to wait. So this problem only amplifies as the network quality decreases, potentially impacting the user experience in a negative way. So the bottom line is clear. People expect speed and reliability. So to address these issues, we need an additional support in place.
So in this project, we devised a prefetching technique to solve such long latency issues. Before introducing our technique, we would like to introduce our observation. We found that the user tend to ask related questions, followed by their first question. As you can see in this tree, after asking the question at the root, the user may want to ask related question 1 and related question 2. Then, based on these questions, the user may continue to ask more related questions like 1/1, 1/2. For example, if a person asks where is Purdue, he or she may also want to learn more about its information, such as when Purdue is founded and what's the Purdue's US ranking. Therefore, we propose a prefetching technique to save time for asking the follow-up questions. That is, when the user asks a question, our design speculatively and simultaneously fetch and cache related questions and answer to the local memory. If the next question hit in the cache, there's no need to send this question again to the server, and we can get the answer from the local memory directly. If it's a miss, the client will send the question to the server as usual. In this slide, we will show how prefetching technique works. We divide the working flow into 3 stages. The first stage is asking questions. The second stage is getting the answer, and the final stage is text-to-speech and pre the answer. For the baseline design that without any prefetching technique, the user will not start to ask the next question until he or she gets the answer of current one. With the prefetching technique, after the first question is sent to the server, the client immediately asks to the server related questions and gets and fetch the answer. Then it conducts the text-to-speech for this answer and cache these related questions and answers in local memory. If the next question hits in the cache, the client can directly play the corresponding answer without the need to accessing the server again. Based on our evaluation, we found that getting answer from the local cache is about 1,000 times to 5,000 times faster than getting answer from the server. We do the server load field tests with different network environments, including the campus Wi-Fi, cellular, and home Wi-Fi. We test this environment with some simple questions, including where is Purdue located, and in what direction is Purdue University from Indianapolis. As you can see in these three figures, different network conditions will result in a different RTT. In this figure, we show that without and with prefetching technique, the performance of our application will be seriously affected. With our prefetching technique, the performance will be significantly improved by around 1,000 to 5,000 times. And let me show our demonstration.
So let's get started. Here you can see different bots or GPTs that you can use if you need a specific guidance or help with any specific topic. Let's go and just do a regular chat. Here, now I will ask a very specific question.
Purdue University is located in West Lafayette, Indiana, United States.
Now, if I press the globe button at the bottom, I should get some network information. So as you can see here, it's the prompt RTT, which is the time it took for the textual based to arrive to the client back from the server. The text to speech RTT that we just heard, so that is in 1400s, and the prompt RTT is in 2300s. We also see source IP and destination IP. So let's verify if the source IP is correct. So as we can see here, the source IP matches what the app found. And let's verify the destination IP now. I'm using an online DNS record to see the IP address for the api.openai.com, and the IP address matches here as well. Along with that, we also have two other information which mentions network type, which is Wi-Fi, and the network name, which is my home. So I'm connected to my home's Wi-Fi right now, so we can see all that information. Now let's try and do one more thing. I will ask the same question again, but I will use speech to text this time. Where is Purdue located?
Purdue University is located in West Lafayette, Indiana, United States.
And if I press the globe button again, I should see RTT for all, including speech to text, because this time I used my voice to give the input. Now let's go ahead and try and optimize this. So what I would do is select the menu, and I would click on the recommendations button. And again, I would ask the same question. Where is Purdue located?
Purdue University is located in West Lafayette, Indiana, United States.
So now we can see, I asked the same question, I got an answer, and if I click here, we can see the RTT information. But along with this, we also asked ChatGPT to give us 3 different related questions and its answers. So what we did was, in the back end, we cached all the 3 questions and answers, which would be ready for the user. Since the user is interested in Purdue University, he or she would be interested in knowing more about it. So let's say I want to know the direction. So if I click that answer,
Purdue University is located approximately 65 miles northwest of Indianapolis.
if you notice, you can immediately see the answer being typed, and you can even hear the answer. That because both the question and the answer are cached locally on the client, and we can verify that by checking the RTT time again. So here you can see the prompt RTT is 1 millisecond and the text-to-speech RTT is 3 millisecond. So that is the benefit of caching related questions on the client side, so that there's no waiting time, there is no issue of any congestion over the network as well. I'll go ahead and cancel this, and I will do one more thing where I'll enable the GPT-4 model instead of the GPT 3.5, and we will test that.
Purdue University is located in West Lafayette, Indiana, United States. It is a public land-grant research university and the flagship campus of the Purdue University system.
And again, this time as well, we can see 3 different recommendations based on the question asked, but this time GPT-4 model provided the answer as well as the recommendations. Now let's go ahead and test the vision model. So I'll take a photo. So as you can see, I'm taking a photo for my watch. And even if I don't write anything, we give it a default text input.
Wristwatch on a wooden surface.
We give it a default input of describe the image, and it describes the image in a simple sentence. Along with this optimization of caching, we have one more optimization wherein we disable the OpenAI text-to-speech. Upon doing this, it uses the Android's local text-to-speech engine to do the text-to-speech conversion. So let's go back to our favorite question.
Purdue University is located in West Lafayette, Indiana, in the United States. It is the flagship campus of the Purdue University system and is well known for its programs in engineering, agriculture, and aeronautics, among others.
This time, if I click the network button, we should see some information. So now we see the prompt RTT was in 33300s, the speech to text was 800, but the text to speech was 8 milliseconds because the text to speech is running locally on the Android client. Let's do one more test where I'm disabling my Wi-Fi and connecting to my cellular service. Where is Purdue located?
Purdue University is located in West Lafayette, Indiana, United States. It is the flagship campus of the Purdue University system and home to its main administrative offices. West Lafayette, along with its adjacent sister city Lafayette, can be found in the northwestern part of the state, near the Illinois border.
Now let's go ahead and check the network info. So here again, we can see the prompt RTT, the speech to text and text to speech. Since we have enabled the optimization to do text to speech locally instead of OpenAI, we can see the difference in the RTT for text to speech. Along with that, the source IP has changed. My network type is now cellular instead of Wi-Fi, and the network name is Verizon instead of the name of the Wi-Fi. Let's try it one more time. Where is Purdue located?
Purdue University is located in West Lafayette, Indiana, United States. It is the flagship campus of the Purdue University system and was founded in 1869 after Lafayette businessman John Purdue donated land and money to establish a college of science, technology, and agriculture in his name. The university is well known for its engineering programs.
So now if I click on the network info, we are able to see that it was connected to the PAL 3.0 Wi-Fi, and we can see the different RTTs for prompt, speech to text, and text to speech. Here we have also enabled exponential backoff, which works in case there is a timeout. It keeps trying up to 3 times, after which it ends the tries and mentions that now we can resubmit the question again.
So in conclusion, our application can simplify the user usage by enabling the prefetching technique and Android TTS NG and exponential backoff. This is the end of our presentation. Thank you for your listening.